Hello students, let's discuss some of the modifications done with the Turing machines. These are also called variations of Turing machines. We all know that a standard model of a Turing machine has an infinite tape, a control unit and a head which is read-write bidirectional head. That means this head can move in both the directions and it is a read-write head. Now we can modify this standard model of Turing machine by so many ways. We can have a machine which has more than one tape, that is called multi-tape Turing machine. We can have a multi-head Turing machine in which there are more than one heads. We can have an offline Turing machine, we will discuss it later. We have non-deterministic Turing machine. We can have a Turing machine with stay option also, and we can have a Turing machine in which this infinite tape, which is two-way infinite in standard model, and we can modify it by making it semi-infinite tape, that is infinite in one direction only. But we have to keep one thing in mind, that doing these variations we are not improving the power of Turing machine. That means the standard model of Turing machine is capable enough, is powerful enough to do all the operations done by these variations of standard models. Let's discuss these modified Turing machines one by one. Our first variation is multi-tape Turing machine, a machine which can have more than one tapes. Initially, input will be on the first tape and the other tapes are kept blank. On a single move, depending on the current state and the current symbol scanned by each of the tape head, this Turing machine can change the state. It can write a new symbol on each of the cells independently and move each of its tape head or keep stationary. That means these head can move independently or may have an stay option also. So if we want to define the transition of this multi-tape Turing machine, let's say we have an instance in which the machine is at state Q1 and at tape 1 it is reading symbol B and at tape 2 it is reading symbol X. Now suppose the transition is defined like that. The machine moves from state Q1 to Q2 and this symbol B, after reading the symbol B, machine changes this symbol to X and this head moves towards right. And for second head you can see the input symbol is X and we are not changing this symbol, so X will be X, but now this time this head moves towards its left. So if you see the next instance of this machine, the instance will be look like this. You can see here that this head is moving towards its right and this head is moving towards its left. Since we have defined here this right movement for first head and this left movement for second head, and you see this symbol which was initially B has been changed into X. So we are doing a right operation, we are changing this symbol B to X. So by this way we can define the transition of this multi-tape Turing machine. Next is multi-head Turing machine. One tape but multiple heads. So a K-head Turing machine has some fixed number of K heads. These heads are numbered from 1 to K and move of TM depends on the current state and on the symbols scanned by each of the head. Each of the head can move left, right or keep stationary independently. And next is offline Turing machine. An offline Turing machine is nothing but a special case of a multi-tape Turing machine. But in offline Turing machine, the input tape is read-only tape. That means this machine will have a special tape in which we will kept the input, and this input cannot be modified. That means this tape is read only tape. Other tapes can be used to write the outputs, and this input tape will be surrounded by some end markers, and this head of this tape cannot move beyond these end markers. So this type of Turing machine is called an offline Turing machine. And next is non-deterministic Turing machines. You can see in this Turing machine we can have more than one transitions for a single instance. So this allows multiple transitions. So the transition function for this machine will be q cross tau to par function of, or you can say the subset of q cross tau cross left oblique r. In standard Turing machine, all the transitions are unique, while in non-deterministic Turing machines, the transitions may or may not be unique. And we have a Turing machine in which we have an option of head to be stationary. That means we can have a choice of stationary head also. So the transition function will be defined like q cross tau to q cross tau cross left oblique right oblique stationary. So this type of Turing machine is called Turing machine with stay option. And the last one is Turing machine with semi-infinite tape. That is a tape infinite in one direction only, that is to the right, and head cannot move beyond the leftmost cell. This Turing machine is called Turing machine with one-way infinite tape or Turing machine with semi-infinite tape.